All right. So, the topic for today is alcohols. This is another sort of a family of compounds, another new homologous series of compounds that you should be aware of. This is something, this is not a hydrocarbon, and alcohol is not a hydrocarbon. A hydrocarbon is one that has only and only carbon and hydrogen, but alcohol also has oxygen in it, right? And its general formula goes like this. Its general formula goes like this: CnH2n plus 1 OH. And once you look at the general formula, one thing that should immediately click your mind is that CnH2n plus 1, it's an alkyl. This is the general formula of an alkyl group. General formula of an alkyl group. So an alcohol is generally an alkyl group bonded with oxygen, and that oxygen bonded with hydrogen, right? In actuality, this oxygen is bonded to a hydrogen. We just don't show it a lot of the time. So this is the general formula of an alcohol. This is the general formula of an alcohol, right? And if you want to talk about the functional group of an alcohol, let's talk about the functional group of an alcohol. Speaking of functional groups, previously we discussed that the functional group of an alkene is carbon double bonded with another carbon. Alkane do not have a functional group, but alcohols do have a functional group, and that functional group goes like this. That functional group goes like this. It is essentially this part right here, right? Carbon bonded with oxygen, and that oxygen bonded with hydrogen. This essentially is the functional group, or you can say it like this. This is the functional group of an alcohol, right? This is the sort of defining part, the part that defines the chemical properties of this family of compounds known as alcohol. And this is essentially the reactive part of alcohol, of an alcohol as well. You'll see how in a bit you will see how this is the part where chemical reactions take place. For example, अगर आप इसे sodium के साथ react करें तो अक्सर औकात what happens is this H plus ion is removed and this Na plus ion comes here instead. So you see, you'll see a lot of those things pop up, right? All right. So again, the basics remain the same. You have N is equal to 1. What is N? N again is the number of carbon atoms. N is the number of carbon atoms. Whenever you have N is equal to 1, again, if you want to draw the displayed formula, let me just draw a table. Number of carbon atoms, and then you have the displayed formula, right? And then you have the naming, right? Then you have the naming. All right. So when N is going to be equal to 1, when N is going to be equal to 1, that is where the suffix is. The suffix is METH, and the prefix, the suffix is, the prefix is METH, and the suffix is going to be ANOL, methanol, right? So ANOL basically gives it away that this particular compound is an alcohol, just like an ANE at the end of the name gives it away that it is an alkane, just like an ENE at the end of the name gives it away that it is an alkene. ANOL gives it away that this particular compound is part of the family of compounds known as alcohols, right? All right. If I were to draw the displayed formula for this one, if I were to draw the displayed formula for this one, you have N is equal to 1. You will have one carbon bonded with oxygen, and that oxygen is bonded with hydrogen. We don't necessarily show this bond as well. All right. So again, now we will. Carbon has one bond already made with oxygen. Oxygen has to make two bonds, one with hydrogen, one with carbon as well. So carbon needs to make three more bonds in order to be, to complete its octet rule. So the three other bonds are going to be with hydrogen. And as you can see, we have one carbon, four hydrogens, and one oxygen. We have one carbon, three hydrogens here, and then an OH. So like this perfectly fits in with the general formula, that is CnH2n plus 1 OH. If N is 1, C1 H2 plus 1 OH. So this is CH3OH, and that is essentially what is happening. If I were to ask you to draw the structural formula out of the displayed formula, you would say CH3OH. You would say exactly this, and that is exactly what is happening right now. Let's do a couple of more examples. Let's say if we have N is equal to 2, if we have N is equal to 2, we have one carbon, a second carbon. This carbon is bonded with OH. This essentially is the functional group. Without this is not an alcohol. And then the rest of it, we add hydrogens to fill the rest of the bond. This carbon has already two bonds. It needs two more. So two more hydrogens attached to it. This carbon has one bond. It needs three more. So three more hydrogens attached to it. And the name of this particular compound is going to be ethanol. And this is the very important very important member of the family of compounds known as alkanes. As you'll see ahead, this has a lot of use cases in the real world, and you will also see ways to make ethanol, a couple of ways to make ethanol, one of which you have already discussed when we did hydration of alkenes, right? That is when we were able to produce alcohols. That is another way we will discuss after this as well. All right. So another example, let's say n is equal to 3. We have 1, 2, 3, and we have this is absolutely essential. Why? Because this is a functional group of alcohols, and then we fill the other bonds. And what will be the name of this compound? The name of this compound will be propanol, right? So on and so forth. Again, the prefixes remain the same. It only and entirely depends on the number of carbon atoms. The suffix remains the same as well. It depends on the class of compounds we are dealing with, and so on and so forth, right? I hope this is clear. Is this clear till now? I don't think there is anything complicated in this. If it is not clear, you can ask the question in the chat. I'll be looking at the chat now. Walaikum assalam. Yes, I do give most of the lectures in English. So if you have any sort of confusion in the way I explained, you can ask me again. Very clear. I am glad it was clear. Let's move ahead then. All right. So about the naming of compounds, let's just say as we were able to sort of name alkanes and alkenes earlier as well. So if I were to tell you the conventions for naming alcohols, right? So again, the functional group is OH, right? The rules remain the same. For example, I'll explain it with an example. It is way better to understand a concept while using an example. If we have this one right here, if we have this one, this is propanol, an alcohol with 3 carbon atoms. This is propanol, actually. So you see, the first rule for naming was choose the longest chain of carbon. You have only one chain of carbon, and this essentially is the longest chain of carbon as well. So we've chosen this one, right? Then we assign numbers. We assign numbers to carbons in such a way that the carbon that is closest to the functional group has the lowest number. So which is the carbon that is closest to the functional group? Either this one or this one or this one. It is this carbon that is closer to the functional group. In fact, it is directly attached to OH. Therefore, this is the part that is the functional group itself, right? This is the part that is the functional group itself. So like the lowest number that will be assigned will be to this carbon. So we start like this. This is the first carbon, this is the second one, and this is the third one. All right. So since this is the way we name carbons, the name of this compound is propanol. The only difference that we're going to be making is we have to give it away in the name of the compound that it is the first carbon that has the OH attached to it. So in order to do that, we will say propane 1-ol, right? This is much like the case where you did, for example, with an alkene, you had this double bond. So you would have named it like prop 1-ene, right? This one shows that it is after the first carbon that we have the double bond, which is also known as the functional group of an alkene. The same way, we will say propane 1-ol. This one essentially means that this is the first carbon. The first carbon has OH attached to it. The first carbon has the functional group with it, right? So this is propane 1-ol. If I were to ask you the name of this compound, right? If I were to ask you the name of this compound, right? Uh, all right. So there you have it. What would the name of this compound be? What would the name of this compound be? If I were to ask you the name of this compound, just follow the rules I just laid out for you. Follow the example I just laid out for you, and tell me the name of this compound. Butane 2-ol. That is the correct answer. That is the only correct answer. Butane 2-ol. Why 2-ol? Why did we do it the way we did it? This was the first carbon, this was the second, this was the third, this was the fourth. Why did we not count it this way? Why did we not say that, okay, this is the first, this is the second, this is the third, and this is the fourth? And why did we not say butane 3-ol? Why? Because the carbon that is closest to the functional group has to have the lowest possible number. This was the closest to the functional group. In the other case, this carbon would have gotten 3 as its carbon number. So we have to assign the lowest number to the one that is closest to the functional group, right? That is closest to the functional group. All right, that is a very good answer. Okay, so what is the name of this going to be? What is the name of this compound going to be? And this is where I want you to think of something that you might not have previously thought of. What is the name of this compound going to be? What is the name of this compound going to be? Ethanol, right? Why not ethane 1-ol? Ishal, why not ethane 1-ol? Why not ethane 1-ol? We can say this is the first carbon and this is the second. Why not ethane 1-ol? Why is that? Why is that? Because either way it's going to only be ethanol. Yes, that is the only correct answer, right? Because even if, for example, even if OH was here and not here, then this would have been the first carbon and this would have been the second carbon. So either way, it had to be ethane 1-ol. There is no possibility where ethane 2-ol exists. There is no possibility where ethane 2-ol exists. So hence the only possible way we can name this is ethanol. So instead of writing ethane 1-ol, we always write ethanol, because it's whenever it's written ethanol, it's always understood that, it's obviously not possible that the second carbon has the functional group attached to it. So this is something I wanted you to know. Perfectly valid answer, Ishil. So is this clear up till now? Is this clear up till now? Yep. Is it clear? I want answers from others as well. I'm Manur. I want answers from each and every one of you. All right. I am glad that this was clear. Okay. So if I were to ask you that as we go, now this is something that is clear. If I were to ask you that this is essentially the homologous series of alcohols, and as we go down, what would happen to the boiling points? Think of the trends we have discussed earlier. This is no different to the logic and the trend that we had discussed in earlier homologous series. The boiling points will increase as we go down the group, and they will increase because the strength of the intermolecular forces increases. This is a question that comes up in the examination just like that. The strength of intermolecular forces increase. This is because the strength of the intermolecular forces increase. And why does the strength of intermolecular forces increase? That is because the number of electrons increase. Of course, the total number of electrons, like counting the number of electrons in each of these atoms, carbon atom, 3 of hydrogen atoms, 1 of oxygen atom, another hydrogen atom. Of course, this one has more total number of electrons than, say, let's say this one. So of course, as the number of electrons increase, the strength of intermolecular forces increases. How exactly? That is not something you should know at this level. This is something that you are taught in your AS level, right? But for now, you just need to know that as the strength of intermolecular forces increases, the boiling points also increase. This is something I wanted to show you as well, that even in this family of compounds, the physical properties gradually change. However, the chemical properties remain the same. Why? Because they all have the same functional group. They all have the same functional group, right? I hope this is clear. I hope this makes a lot of sense, actually. Let's go ahead and let's see some use cases for alcohols, right? Before we move to the ways in which alcohol can be produced, let's talk about some of the uses of alcohol in real life. Some uses of alcohol. Actually. And let's talk about ethanol in particular, right? And ethanol is an alcohol. Let's talk about some of its use cases. What could be some of its use cases? A very important use case can be that it is used in perfumes, right? You have these alcoholic perfumes that smell so nice. They are all having ethanol as a common ingredient. And this is something that is used, right? Ethanol is also used as a solvent. Used as a solvent. If you have already studied the chapter of salt preparation, you must have come across the term that dry the salt using an organic solvent. That organic solvent is ethanol. Why do we use ethanol? Why don't we use water? In many cases, we have some substances that dissolve in water, that do not dissolve in water. I beg your pardon, that do not dissolve in water. So when they are unable to dissolve in water, then we use ethanol as an alternative so that ethanol can dissolve those substances. So it is used as a solvent where the substances cannot be dissolved in water, where the substances cannot be dissolved in water, right? And oh, by the way, if they ask you the reason as to why an ethanol can be used in perfumes, that is because ethanol is volatile. It can evaporate very easily. The fact that it is volatile, it can evaporate very easily, leaving behind the scent that lays there on your skin, right? So you see, that is why it does not just stay there, it just evaporates. You don't feel that liquidy sort of perfume laying on your skin all day long. It is just the fact that the liquid part evaporates so that you only have the fragrance left and you smell nice the whole day. So that is another use case for it. It is also used in medicines and stuff, but these are the two very important use cases of ethanol, right? And this is something you should be able to know. Let's talk about the ways to produce ethanol. If you have any questions up till now, you may ask so. Let's talk about the ways to produce ethanol. Do you guys have any questions? I will look at the chat after this. Let me look at the chat for a moment. They decrease down the series. Yes, I hope it is clear. I Okay, perfect, perfect. I am glad that you don't have any more questions. Actually, so let's talk about two ways. Let's talk about two ways. One way of producing this is through an addition reaction in alkenes, in particular hydration in alkenes. What is hydration in alkenes? We discussed that in an earlier class. Let me go through that again. Hydration and in alkenes would essentially mean adding water in its gaseous form, that is steam, to alkenes, and that water will add itself. The OH part of the water will attach to one of the carbons that initially had a double bond. The H will attach to the other carbon that initially had a double bond, and as a result what will form is an alcohol. Back then you did not know much about alcohols, but I gave you this general idea, and let me go through this again. All right, so this was that example. You see, hydration is a type of addition reaction that alkenes undergo. Again, this is a sort of reaction that alkenes are specific to, that is specific to alkenes. Addition of water in the form of steam. We had certain conditions. The conditions was a very high temperature, around 5770 degrees Celsius. You might see 360 to 370 pop up in some mark schemes as well, and that is also perfectly valid. But this is something that is more often than not safe, right? The other condition was a 60 to 70 atm pressure. This is a good enough pressure. Why? Because pressure has to be applied on reactions involving gases. Since steam is also a gas, ethene also usually exists in a gaseous form. We do apply pressure on reactions involving gases. And then we used as a catalyst H3PO4, which is phosphoric acid. What happened as a result was again the same mechanism that happened in the earlier addition reactions in bromination and in hydrogenation. What happened was that the double bond broke. Both these carbons were left with three bonds, and both of them needed their fourth bond. So what happened was that the hydrogen attached itself to one carbon, and OH would attach itself to the other carbon. And as a result, now you can see this displayed formula perfectly matches the description of the general formula of ethanol. The general formula of ethanol, right? And you see CH3, CH2, essentially Ce2H5. This is the ethyl group, and then the OH. This perfectly gives it away that this is an alcohol, right? And this was one of the ways to produce alcohol. This is a perfectly acceptable way to produce alcohol, because you see the product that is produced is alcohol. The product that is produced is ethanol. So if on an industrial level, if you wanted to produce ethanol, what we would do is we would take an alkene, right? We would take ethene, we would react it with steam, we would apply these conditions, and as a result we will produce ethanol. There is another method, however, however another method to produce alcohol, and that is something we are going to discuss now. And then we will discuss the advantages and disadvantages to each of these methods, right? Then we will discuss the advantages and disadvantages. But the other method is fermentation of glucose, right? And that is a very interesting, a very sort of interesting way to make ethanol, and it has some benefits over this other method that we just discussed. All right. So talking about fermentation, what do we know by fermentation? If any one of you is taking biology by any chance, you would know that fermentation is a biochemical reaction. It is a biochemical reaction. Why? Because we have living organisms as part of it. This is a biochemical reaction, right? What do we mean by a biochemical reaction? It does mean that we have living organisms as part of this reaction, right? The earlier reactions that we did, we obviously had chemical substances, but we did not have any living substances that were actively partaking in the reaction. So the fact that this reaction has a living organism, and we'll see how exactly does it have them, we refer to it as a biochemical reaction. That living organism can be yeast, it can be bacteria. Let me write this correctly. It can be due to yeast or bacteria. right? And yeast and bacteria are microorganisms that are living organisms, right? These are essentially living organisms. However, they are so small, we refer to them as microorganisms. We refer to them as microorganisms. All right. So we have certain conditions for this reaction to take place. We have certain conditions. Again, these are the conditions you need to remember, just like the conditions for earlier reactions. That is something you can be actively asked to mention in your examination. All right. So the first condition is that we will use a reagent, and that reagent could be aqueous glucose, right? And the formula for glucose is C6H12 and O6. This is the reagent. This is the very, very important reagent that we will have to use in order for the reaction to proceed, right? This is the reagent. I will write that down as reagent. So this was the first of the couple of conditions that you are supposed to know. The other condition is no air. We must not expose this to air. Air must be absent. Why must air be absent? Or you can write this as absence of air. That is perfectly fine as well. Why should air be absent? Because if you were to expose this to air, what would happen would be C6H12O6 glucose would react with the oxygen in the air, and it would undergo combustion, and as a result would form carbon dioxide and water. And that is essentially the process of respiration that occurs in the human body. We do not want this to happen, because you see, there is no ethanol being produced. Our goal is to produce ethanol. So in order for this to not happen, in order for glucose to not even be exposed to oxygen one bit, we make sure that there is absence of air. There is absolutely no air that this is exposed to. Then we have another very important condition, and that condition is the temperature of this reaction. The temperature of this reaction should be around 18 to more or less 35 degrees Celsius, right? 35 degrees Celsius, right? And why is that? Why not greater than 35? Why not greater than 35? And why not less than 18? Why not less than 18? The reason for that is the enzymes that are present in the reaction. If you know biology one bit as well, even if you don't, this is something you don't really need to know per se, but enzymes are biological catalysts. Are biological catalysts. They are catalysts found in the human body. They are catalysts found inside of living organisms, because we have tons of chemical reactions going on in the living organisms, and we have some naturally occurring catalysts in our body, and those catalysts are known as enzymes. Those catalysts are known as enzymes. So you see, those enzymes have a particular temperature at which they work best, and that temperature is known as the optimum temperature. This is just to give you a little context as to why this is the temperature range and not something apart from it, right? You see, if the temperature is greater than 35, enzymes are made up of proteins, and those proteins get denatured. The shape of the enzyme gets disturbed, and then it is not able to catalyze the reaction well, right? For example, if the enzyme is shaped like this, its shape will completely distort, and then it will not be able to catalyze the reaction properly. So it cannot be greater than 35 degrees Celsius, and it cannot be less than 35 degrees less than 18 degrees Celsius as well, because again, then that is not a good enough temperature for the enzymatic activity to work at its best temperature, right? So this is generally a range that is safe to work with in this reaction. And this the reason, and the catalyst for this reaction is, I usually tell you the catalyst of this reaction. The catalyst is the enzymes. The catalyst is essentially the enzymes that come from yeast, right? We don't add an external sort of catalyst like we did earlier, right? In earlier reactions, we had H3PO4. In some reactions, we had Al2O3, we had nickel, right? But those were the catalysts we added ourselves. In this reaction, the catalysts are naturally occurring. They are enzymes that are already part of the living organisms, right? And those enzymes are the catalysts that catalyze this reaction, right? So if they ask you what is the catalyst for this reaction, you have to say that the enzymatic activity of yeast, or the enzymes that come from yeast, will catalyze the reaction. Is this clear up till now? Is it produced after the anaerobic respiration of yeast? Sabine, that is something you should not know, and I would not recommend you to get into that debate as well, because I don't remember seeing that come up in the past papers as well. Not too hot, or the microbes might denature. Yes, not necessarily the microbes. It is the enzymes that might get denatured, because an enzyme is made up of protein, and protein are very sensitive to changes in temperature, right? So I think that is a better term. I'm not sure if microbe would be 100% correct. Of course, I don't teach biology, so maybe that is technically the correct term, or maybe not. So if you have any more questions, do ask before I proceed. Do ask before I proceed. Rafiq, Mahnur, welcome Rafiq. I think this is the first class you've been part of. Isa, is it clear? Daya, is it clear? Ahmed Anwar, welcome to the class. Is this clear to one of you? Can we say the above 35 won't take place? Again, it's not necessary that the moment you increase it from 35, the moment you increase it from 35 to say 35.2, the reaction is not going to take place. But of course that is, not the, that is greater than the optimum range. But obviously if you expose it to a temperature of like 80 degrees Celsius, then obviously the reaction will not take place, because it would denature the enzyme to such a degree that the reaction might not even take place in the first place, right? So just say that this is the optimum temperature. And if the question comes up and asks you that why not a greater temperature, just say that it is a too high of a temperature for the enzyme. It will denature the enzymes and it will not catalyze properly, right? But again, those are biological questions. Those are questions that stem from biology. You will not be expected to answer these in your examination. This is something just I just told you so that you have a better idea of how things work. Different enzymes have different optimum temperature. Yes, different enzymes have different optimum temperature. One size does not fit all. All right, Manur, I am glad you got it. Okay, so let's write an equation for this reaction. Let's write an equation for this reaction. And by the way, this is an exothermic reaction. This is an exothermic reaction. This is something you should know, that this is an exothermic reaction. This is an exothermic reaction. Exothermic in nature. So what happens is that it will release heat energy, right? It will release heat energy. All right. So let's write the equation of this reaction. The equation for this reaction goes like this. We have C6H12O6, and this is going to be aqueous. Why? Because I told you, when I told you that the reagent for this reaction is going to be aqueous glucose. It is going to be aqueous glucose, right? And what happens is we apply these conditions. We say that, okay, no air. We say that 18 to 35 degrees Celsius is going to be the temperature. The enzymes that come from yeast are going to catalyze this reaction, and as a result, what is going to happen, what's going to get produced is C2H5OH, and this is ethanol. What's going to get produced is CO2, and what's going to get released is heat energy, right? Heat energy is going to get released. You have heat energy here, right? Let's balance this equation. 2 into 2, 4. We have this equation balanced. And what will happen as a result? The carbon dioxide that is going to get released is going to be in gaseous form. The glucose is going to be in aqueous form. The glucose is going to be in aqueous form. All right. Is this clear up till now? Is this clear up till now? If you have any questions, do ask. If you have any questions, do ask. Right, this is the equation that you should be able to write in your examination. You must know that, okay, whenever we have glucose as a reagent, we expose it to these temperatures, and we have yeast, and the enzymes that come from yeast, they act on it, and we make sure that no air is there to act on to make this glucose combust. Then as a result, what will form is an ethanol, carbon dioxide. What will form is aqueous ethanol and carbon dioxide. Aqueous ethanol and carbon dioxide. Now what happens is this aqueous ethanol, let me write it on a new page for you. The yield of this aqueous ethanol, the yield of ethanol is more or less 15%, right? It can be something like 12, or it can be something like 18. I like to call it all more or less 15%, right? This is the yield of ethanol. This is not 100%. This is not 100%. And why is it not 100%? Let me explain the reason to you guys. All right. So what happens is that as the reaction is taking place, as the reaction is going in this direction, what's happening is that more and more of ethanol is being produced. But at one point the yeast stops working. And when the yeast stops working, obviously the enzymes that the yeast has, obviously they don't work on that reaction as well. So when the yeast stops working, the production of ethanol also stops. So that is the point that when the yeast stops working, at that point, usually you have 12 to 18% ethanol being produced, not more than that. And why does the yeast stop working? Because as you see, this is an exothermic reaction. It is continuously releasing heat. So when the heat gets too much for the enzymatic activity to take place as it would, when the heat gets too much and there is, for example, a threat of denaturing the enzyme, so the yeast stops working. The yeast stops working, and as a result, the production of ethanol is halted at somewhere around 15% yield. At somewhere around 15% yield. Is this one clear? Is this part clear? It's a little complicated to understand, but I hope this part is clear. Type in the chat if it is. I'm just trying to make sure that everyone gets what I'm saying here. There is absolutely no point if I just keep on blabbering stuff and you guys don't understand what's going on. Is this clear? This is clear, Tabeen. I am glad. I hope it is clear for everyone else as well. All right. Okay. So we have this as one of these methods. And again, this is all right. And one other thing I want you to notice, one other thing I want you guys to notice is that this ethanol being produced is impure. This ethanol is impure. And why is it impure? Why is it impure? It's because this is aqueous. We want ethanol in its absolute raw form, in its absolute, in such a state that is found at RTP. We do not want it aqueous. We want it pure. So it is impure as well. So that is one of the disadvantages of this reaction. That is one of the disadvantages of this reaction. So let's talk about a disadvantage of this reaction. So we have an advantage and we have disadvantages to this as well, and then we will compare these two approaches, one where we do hydration of an alkene and one where we make it undergo fermentation, make glucose undergo fermentation, and see which is an actually a better method to produce ethanol. So a disadvantage of this is that ethanol produced is impure. Ethanol is impure. Pure ethanol has to be obtained through a method of purification, is obtained through fractional distillation. And we will go into details of fractional distillation in the future. That is something that is a very important topic. Separating techniques and purification techniques is a very important topic. But pure ethanol is obtained through fractional distillation. The fact that we have to make it undergo fractional distillation to obtain pure ethanol is a disadvantage in itself. It costs you money, it costs you your time. So obviously it is a disadvantage. However, if we were to talk about an advantage would be that glucose comes from a renewable energy resource. A renewable energy resource that can be produced over and over again, and there is almost very little fear of it running out. You see, it comes from a renewable energy resource. For example, if you think about glucose, there are many naturally occurring substances that contain glucose in itself. For example, we have sugarcane. A very good example is sugarcane. Sugarcane does contain glucose, and sugarcane is renewable. You don't have the fear that sugarcane may run out one day. So, again, an advantage is that glucose comes from a renewable energy source, from a renewable source, and that is a very big advantage of this reaction. Compare this to, let's say, the method of production of alcohol with hydration in alkenes. It came from alkenes. Alkenes in and of itself are not renewable. They are non-renewable. Their supply is very limited. So this is an advantage and a disadvantage of this particular method of, forming ethanol, of producing ethanol. Is this clear? Rafiq, is it clear? Mahnoor, Daya, Isa, Ahmed, everyone. Is this clear up till now? Type in the chat if it is. Type in the chat if it is. Yes, I am glad it is clear. Just one more little concept before we move to a couple of past paper questions and before we call it a day for today. All right. So give me a moment. Tomorrow we will be doing carboxylic acids then, and after that esters. Then we'll have polymerization, and then we will be done with organic chemistry. I think we will have 2 or maximum 3 more days for the master class to proceed, right? So that is how it would go. All right. So I think that is the only concept you would need to know. Let me share my screen again. Can you scroll? Yes, I can scroll up a bit. Usually, in case you're making these notes, you don't really need to. The reason for that is I will provide you these notes once the master class is done, right? But if you still prefer to write things down, you can do so. All right, I am scrolling up. Tell me when to stop. All good, thank you. All right, I am glad it helped. Okay. So let me share my screen. Let me bring you to another window, and let's just do some past paper questions.